In this video, I'm going to go through some challenging problems in rate of change. The first one is find points PQ on the parabola y equal 1 minus x squared. So the triangle ABC formed by the x-axis and the tangent lines at P and Q is equilateral triangle. So let's just draw this parabola. Our parabola is y equal 1 minus x squared, which is the same as negative x squared plus 1. So this says that the vertex is at 0 and 1. So the vertex is here. Now the x-intercepts are when y is equal to 0, so x squared is equal to 1. So from here we get x is plus or minus 1, which are going to be points here. So our parabola, which looks like this shape. Now we have to find 2 points P and Q such that if I draw the tangent, let's say P is here, Q is here, then the tangent, one of them is here, the other one is going to be here. If I call this triangle A, B, C, and this point O, triangle ABC is equilateral. First of all, we know that triangle is equilateral, so all these inside angles, interior, has to be 60. So this angle is 60. So from here I can say that the tangent of angle 60 is equal to AO over OC. But the tangent of 60 is square root of 3 over 1. Now if we look at this one, AO over OC is just the slope of the line AC. So this is M, the slope of the tangent line. Now the tangent at point P, let's say point P is A, and if x is A, then the y, I just put it back in the equation, becomes 1 minus a squared. Let's use the first derivative of y to find the slope. We know that y prime is negative 2x. Either we can use the formula that we derived in class. Remember, we found that the derivative of a monomial function of the form x exponent n is nx exponent n minus 1. Or we can use the difference quotient. Now the slope at point P, which has x value of a, is going to be equal to negative 2a. This means then the slope of this line, which is going to be rise over run, has to be equal to negative 2a. But as you can see, the line AC is falling, so the slope is negative. And the slope we found was, the absolute value of the slope is square root of 3 over 1. So we can say negative 2a is negative square root of 3 over 1. So from here I get a is square root of 3 over 2. So this means that our a value becomes 1. So y is 1 minus a squared, which is square root of 3 over 2 squared, which is 1 minus 3 over 4, which is 1 over 4. So this means that my first point P has the coordinates square root of 3 over 2 and 1 over 4, and point Q, which is the reflection of point P on the y-axis, is going to have the coordinate negative square root of 3 over 2 and 1 over 4. The next question says find the point where the curves y equal x cubed minus 3x plus 4 and y equal to 3 times x squared minus x are tangent to each other, that is, have a common tangent line, and also sketch both curves and the common tangent, which you can do it yourself using Desmos or do it manually. So that part I'm going to leave it to you to do it. But the first part, to find that point, let's say the point that the tangents they meet, or the tangent meets the curves to be point A, and now since point A is the x coordinate, I can put it in any one of these equations and find point y. Let's say I put in the second one, I get 3 times a squared minus a. Now the slope of the first curve is 3x squared minus 3. If we evaluate it at this point where x is a, this gives us 3a squared minus 3. The derivative of the second equation, if I expand it, y is 3x squared minus 3x. The derivative is going to be 6x minus 3. If I evaluate it at this point with x equal to a, I get 6a minus 3, which has to be equal to the first slope. If I solve this one, negative 3 goes with negative 3, I get 3a squared minus 6a is equal to 0. So from here I get 3a times a minus 2 is equal to 0. So a has to be equal to either 0 or a has to be 2. Now, if a is equal to 0, the point, which is this one, that the two curves, they touch each other, becomes 0, 0. Now, if we look at this point, when you put the x equal to 0 in the first equation here, you get 0 cubed minus 3 times 0, which is 0 plus 4 is 4. And this is not equal to 0 here. So this means I have to drop a equal to 0. It's not a valid answer. Now let's check the second point, the a value, which is 2. If a is 2, then this point becomes 2 comma 2 squared is 4 minus a, which is 2. So 4 minus 2 is going to become 2. 2 times 3 is 6. Now let's check to see if this point is on this graph, the first one. When x is equal to 2, 2 cubed is 8, minus 6 is going to be 2, plus 4 is 6. So this is okay. Now the second graph, if I put x equal to 2, 2 squared is 4 minus 2 is 2, 2 times 3 is 6, so this is okay. So this means that a has to be equal to 2. So when a is equal to 2, my slope becomes either 3a squared minus 3, which is this one, or 6a minus 3. So I can find the slope to be, let's say the second one, 6 times 2 minus 3, which is 9. So my equation becomes y is equal to 9x plus b. But this line has to go through this point. So if I sub it back here, I get 6 is equal to 9 times 2 plus b. So b is equal to 6 minus 18, which is negative 12. So this means that my equation becomes 9x minus 12. Go ahead and use Desmos, plot this curve, plus plot this curve, and plot this line, and you would see that at the point that these two curves they touch is the same point that the line y equal 9x minus 12 goes. The next question, we have a car which is traveling at night along a highway shaped like a parabola with its vertex at origin. The shape is given here. The car starts at point 100 west and 100. So we can say that the coordinate of the car is negative 100 and 100. There is a statue at location 150. So this position is 100 and 50. Now we are supposed to find the point on the highway that the car's headlights illuminate the statue. This means I have to find the tangent line to the curve somewhere around here, which goes through this point. This point where the tangent touches the curve is where the car is supposed to be. So I have to find this point. Let's call this point with the x coordinate A, and the y coordinate is going to be the equation of the curve. Now, to find the equation of the curve, I know it's a parabola, so I can write the equation as y equal to a times x minus h squared plus k. We know h is going to be 0 and k is going to be 0, so it's going to be ax squared. This is the equation of the line. But I know the curve goes through the point negative 100 and 100. So I can say 100 is equal to a times negative 100 squared. From here, I can find a is equal to 1 over 100, which is 0.01. So the equation of the curve becomes 0.01 x squared. Now, if the tangent line touches the curve at point x is a, so the y is 0.01 a squared. So this is the equation of the curve. Now I have to find the derivative to find the slope at this point. So I say y prime is 2 times 0.01x, which is equal to 0.02x. Now, at point, let's call this point A. At point A, x is a. So this means that the slope, we call it m, is 0.02a. So this means that the tangent is equal to mx, which is 0.02a, plus b. b is the y-intercept. To find the y-intercept, I know that the line goes through this point, which is 150, the statue. So I'm going to sub it back here. So I'm going to get 100, which is 50, which is y is equal to 0.02 times a. Oh, there is an x here for the equation. Y equal 0.02 ax plus b. So it's going to be 0.02 a times x. X of this point, the statue, is 100 plus b. So if I simplify this one, I get b is 50 minus 2a. So the equation of the line becomes y is equal to 0.02 ax plus 50 minus 2a. Now, I also know that this tangent line goes through this point, so it has to satisfy the x and y coordinate. So if y is 0.01a squared, so 0.01a squared has to be equal to 0.02a times x. X is a, so it becomes a squared plus 50 minus 2a. I'm going to move this one to the right. 0.02a squared minus 0.01a squared becomes 0.01a squared minus 2a plus 50 has to be equal to 0. Now this is a quadratic equation, and I'm going to use quadratic formula to solve this one. So a becomes minus b, which is 2, plus or minus b squared, which is 4, minus 4ac. So 4 times 0.01 times 50 divided by 2a. 2 times 0.01 is 0.02. If I solve this one, I get two values for a, either going by the positive here or negative. If I go with positive, I get 170.7 for a. If I go negative, I get 29.3. Now, I have to drop this one. The one that a is 170.7. Remember, a is the x-coordinate of the point that it touches the curve. Now, the x-coordinate of the statue is 100. 170 for the x-coordinate is going to be somewhere around here, which is impossible. So this is not the one we are looking for. So the only valid answer is 29.3, which is going to be to the left of the statue, which is correct. Now, to find the y value of the point of intersection, I'm going to evaluate 0.01a squared when a is 29.3. If you use your calculator, you get the point of intersection is 29.3, which is the x value, comma 0.01 times 29.3 square is going to give you 8.58. So this means when the car reaches 29.3 east of the origin here and is 8.58 kilometers north of the horizon, then the headlight is going to illuminate the statue. The next question says, for what values of constant c the function is continuous on the real numbers from negative infinity to plus infinity. To do this one, we know that for the function to be continuous, it has to have the same limit left and right at every point in its domain. Let's look at the value 2. The limit of a function when x goes to 2 but from left is equal to, because it goes from the left, I have to evaluate this function at x equal to 2. If I put x equal to 2 here, I get 4c plus 4. The right limit when x goes to 2, I have to evaluate this function. This means 2 cubed, which is 8, minus 2 times 3 is 6, which is going to give me 2. Also, the left and right limit, they have to be equal to the value of the function at 2, f of 2. f of 2, we have to evaluate this function again. This means 2 cubed 8 minus 6, which is 2. Now, this one, and this one, they have to be all equal, so the function is continuous. This means 4c plus 4 has to be equal to 2. So 4c is equal to 2 minus 4, which is negative 2. So c has to be negative 2 over 4, which is negative 1 over 2. The next question says, we have a function f of x is equal to 2x minus 2. It has two tangents which are drawn at x equal to negative 2 and x equal to 2. Find the point of intersection of the tangent. So the function f prime, which is the slope, is equal to derivative of 2x squared minus 2, which is going to be 4x. So the first slope is when x is equal to -2, so m1 becomes 4 times -2, which is -8. The second slope, m2, is when x is 2, so we get 4 times 2, which is equal to 8. So for the first equation becomes y equals -8x plus b. And the second equation, y2 becomes 8x plus b. Let's say b1 and b2, different y-intercepts. To find the y-intercept of the first equation, this one, I know that it goes through the point -2, but we can find the y-coordinate of this point. We know that -2 is the x, so I put it back in the equation. I get 2 times -2 squared is 4, so it's 8 minus 2 is 6. So I know it goes through the point -2 and 6, so from here I get 6 is -8 times -2 plus b1. So from here I get b1 is 6. -2 times -8 is 16. Goes to the left, becomes -16. So b1 is equal to -10. So the first equation becomes -8x, -10. The second equation, we know that it has to go through the point 2. Now if I put 2 back in the equation, I get 2 times 2 squared. So it's 2 squared is 4 times 2 is 8. 8 minus 2 is 6. So it goes through the point 2 and 6. So if I put it back in this equation, I get 6 is equal to 8 times 2 plus b2. So from here I get b2 is 6 minus 8 times 2 is 16, so which is going to be -10. So the first equation, the second equation becomes y2 is 8x minus 10. Now, these are the two lines. To find the point of intersection, I'm going to use elimination method, and I'm going to add these two equations. So if you add these two equations, -8x with 8x, they are going to cancel, so I get 2y is equal to -20. So from here I get y is -20 over 2, which gives me -10. To find the x coordinate, I put it back in either of these equations. I get the x value to be, if y is -10, so I get -10 is equal to -8x minus 10. -10 cancels with -10, so I get x is equal to 0. So this means the point of intersection of the tangents is 0 and -10. The next example is asking to find the equations of the tangent lines to the curve y equal to x squared plus 3 that passes through the point 2 and -7. First of all, if you look at the point 2 and -7, if I substitute x equal to 2 in the equation here, y becomes 2 times 2 squared, which is 8, plus 3, 11. So this means point 2 and -7 is not on the curve. Let's say the equation of the tangent line which touches the curve at the point, let's say A. Now to find the y value, I put it back in the equation. It becomes 2a squared plus 3. So this is the point where the tangent touches the curve. The slope of the tangent can be found by finding the derivative of a function at point A. X equal to A. So y prime becomes 4x. So from here, the slope m is 4a. So this means that the equation of the tangent becomes y mx, which is 4a x plus b. But since it touches at this point, it has to satisfy the y coordinate. So this means that 2a squared plus 3 is equal to 4a squared plus b. So from here, I get that b is equal to negative 2a squared plus 3. So the equation of the tangent becomes y is equal to 4ax plus b, which is 3 minus 2a squared. Now the tangent has to go through this point. So negative 7 is equal to 4a times 2 plus 3 minus 2a squared. Now if I move everything to the left and simplify, I get 2a squared. Then 4a times 2 becomes negative 8a, and 3 goes to the left becomes negative 3, so negative 10 is equal to 0. If I factor out 2, I get a squared minus 4a minus 5 is equal to 0. Since the leading coefficient is 1, I can use sum and product. So I have to find two numbers. The product is negative 5 and the sum is negative 4. Those two numbers are negative 5 and 1. So I can write this one as a minus 5 times a plus 1 is equal to 0. So from here, I get a is equal to 5 or a is equal to negative 1. So the equation of the lines of the tangents become y is equal to 4a times x. A is, let's say, 5. So 4 times 5 is 20x plus 3 minus 2a squared. So it's going to be plus 3 minus 2 times 5 squared. So this gives us y is equal to 20x. 5 squared is 25 times 2 is 50. So 3 minus 50 is negative 47. So this is one of the tangents. The other one, y is equal to 4a. A is negative 1, the next one. So negative 4x plus 3 minus 2a squared. So it's going to be 2 times negative 1 squared. So this gives us y is equal to negative 4x. Negative 1 squared is 1. Negative 2 times 1 is negative 2. 3 minus 2 is going to give us plus 1. So the two tangent lines are y equal to 20x minus 47 and y equal to negative 4x plus 1.